This micro-credential deals with virtualized systems consisting of 4 targeted skills. This targeted skill is about virtualization basics. Virtualization is a method of assigning the resources of a computer in such a way as to allow for the operation of 2 or more independent operating systems simultaneously. In other words, virtualization is running a computer inside a computer. In normal computer operation, the operating system is installed directly on the hardware. Part of the operating system, called the kernel or supervisor, handles the interaction between hardware and software, as well as assigning resources for system operation. To enable virtualization on a computer, special software called a hypervisor or virtual machine manager (VMM) must be installed in the system. The hypervisor functions similarly to the kernel that has complete control over everything in the computer system and allows for the creation of the virtual machines as well as the delegation of resources for them. The physical computer is called the host system, and each virtual machine is called a guest. The host and each running guest share the physical computer's resources, such as memory, which limits the type and number of virtual machines, VMs, that can run simultaneously. However, VMs only exist as a saved file on the host computer and don't use any system resources unless they are actually running. This means that the number of VMs created is only limited by the available storage space on the computer. Creation of a virtual machine is not complicated. The user opens the hypervisor and configures the system resources, including processor cores, memory, and virtual hard drive space. The first time the VM starts, installation of the operating system occurs just as it would on a physical machine. Afterwards, the VM boots like a normal computer. There are many benefits to virtualization. One of the most important is conservation of resources. Prior to virtualization, every installed OS required a different physical system. Organizations needed multiple servers to support their operation and provide for failover and redundancy. Many of these systems were underutilized. Virtualization allowed for the installation of multiple virtual systems on a single physical machine, taking advantage of this excess capacity. Fewer physical machines means less space needed to house them and less power needed to run them. However, virtualization doesn't reduce licensing requirements. Each virtual machine must still be licensed by following the same model as those for a physical machine. Virtual machines also help improve reliability. Since VMs exist as a file on a drive, snapshots that are copies of the file can be made. These snapshots capture every aspect of the machine at a given point in time. If the VM's operating system becomes corrupt or infected with malware, the snapshot can be quickly restored. If the host computer goes down, the snapshot can be transferred to another host. Another advantage is scalability. As an organization grows, it only needs a provision of an additional virtual machine as opposed to purchasing another physical server. Resources can also be added to previously created VMs by changing those settings in the hypervisor. Other aspects of virtualization include testing and sandboxing. Testing allows network administrators or developers to install software on a machine to see how it interacts with other software. Testing, prior to installation on production machines, can discover problems and save downtime. If a technician wants to test unknown or untrusted software, it is best done on a standalone system that is isolated from other machines. VMs run in a restricted execution environment called a sandbox that are separate from the host OS and can be used for this purpose. Finally, a lot of people confuse virtualization and emulation. Virtualization allows for a single host machine to run multiple operating systems at the same time. However, each of those OSs is designed to be run on that hardware. Emulation involves running software on hardware that it isn't designed to run on. An example is trying to run Android, a mobile operating system developed by Google, on a personal computer. Android is designed to run on phones and tablets which use an entirely different system architecture than a PC. For Android to run on a PC, an emulator needs to translate and instruct the PC hardware to mimic the phone or tablet architecture. In this targeted skill, a basic level of knowledge was provided concerning virtualization and its benefits to users.